Hey, let's solve this SAT question. I'm sure you've already read this multiple times if you're here on YouTube, so let's get started. On the left here is the question, and on the right I'm going to be working. The first thing I see is these negative WYs on top of each other. They're literally on top of each other. The SAT is trying to tell us here, maybe you should use the elimination method. So that's what we're going to do. So we need to add these two equations together to where one of these variables cancels out. So I'm going to go with this WY here by multiplying this bottom equation by -1 to get this. And now we can cancel these out when we add both of these equations to each other to get -3x equals -384. Now we're going to divide both sides by -3 to isolate our x, which is equal to 128. From here, the work is on the left, and I'll be working with this x. Now, you need to choose an equation to plug x back into, and in this case I just chose the top one, but either one is fine. So let's plug that in, and then as you can see, we can add 128 to both sides to get negative WY is equal to -209. From here, we can divide both sides by -y to get W equals 209 over y. And as you see here, we can take this y from this question because it says in the xy plane, the graph of these equations intersect at the point something, comma, but we know that y value. So here we can plug in that y value and then solve for w, which is equal to 11. Now, this is a great method and it tests our elimination skills, but we can also use Desmos, which they give us in the SAT, which is extremely helpful, and I use it for almost every problem. So I've plugged in just these two equations from over here, and in this case, we can just add a slider, I think would be the easiest way. So we have our two equations, but then we have to go back. What are we trying to find? We're trying to find what is x when when they intersect at y is equal to 19. So we're going to put y is equal to 19 to get this line here. This red line is our y is equal to 19. And we can just drag this around until they both intersect. So let's zoom in a little bit. Intersect. And if you get to this point, you can just click on it and at it, let's say we'll go to 15. So we can continue sliding it up. We're getting close. Looks like they intersect perfectly on W is equal to 11, which matches our previous answer that we found algebraically. So Desmos, extremely helpful, and I hope this helped.